So as we begin to graph rational functions, we want to be able to determine the horizontal asymptote of a rational function and graph rational functions that have only vertical or horizontal asymptotes. All right, an asymptote. An asymptote is going to be a line or a point on the graph that the graph approaches but never touches. So for example, a horizontal asymptote is a horizontal line that a graph approaches as x goes to positive or negative infinity. So that graph just may look fairly simple, that as I go, it looks like this graph, just looking at it, where we have our x and y, as my x gets increasingly smaller, right? As my x gets increasingly smaller, as it approaches 0, my y value is increasing. And that is what happens. It looks like it's never going to cross over the y-axis. So it is going towards infinity. So the value of 0 is not allowed in the denominator, apparently, for that's my vertical asymptote. And then the horizontal asymptote would be where it looks like, in this case, this graph looks like it, as x continues towards infinity, my y is decreasing towards 0 because it seems to be approaching the x-axis but never touching. And that's just looking at a very basic asymptote example. And we are going to go into those, and as we talk about vertical asymptotes, these are basically going to be the real zeros of the denominator. Things that do not exist, things that we can't have in the denominator, which would make them an undefined term. So when we look at this, my vertical asymptotes, again, strictly dealing with the denominator. And you look at the denominator, make it equal to 0. In this case, I would have x plus 1 equals 0. So again, negative 1. X is going to be negative 1. The vertical asymptote is going to be x is negative 1. It's just that easy. So if I were to graph that, I would turn around and know that at negative 1, I'm going to have this imaginary line that the function can never touch. And when x is 0, think about it, if we plug 0 in for x, 0 here, it looks like we're going to have 0. And then when x is negative 2, we're going to have a negative number. But anyway, just throwing some numbers in there to try to figure out what's going to graph it. But so this function can never be negative 1, because if we plug negative 1 in there for x, it would be an undefined denominator. So my vertical asymptote is negative 1. Looking over here, looks like here my function is, the denominator is going to be x minus 3 squared is equal to 0. And, we don't need to do this, but I know that x minus 3 squared is x minus 3 equal to 0. So x minus 3 equals 0, so that is going to be plus 3 plus 3. And another vertical asymptote is going to be x is equal to 3. So if the function will never, the domain is going to be all real numbers except for 3. The domain here is going to be all real numbers except for negative 1, because x can't be negative 1. Here, all real numbers except for x is 3, because x can't be 3, because if we had 3 minus 3, that would be 0, and we can't have 0 in the denominator. All right, so continuing on here to this one. Take the denominator and make it equal to 0. And in this case, you may recognize that that is the difference of squares. So I have x minus 1 times x plus 1 equal to 0. So x minus 1 equals 0, or x plus 1 equals 0. And then x is going to be negative 1, or x is going to be 1. And so we're going to have two asymptotes, two vertical asymptotes, and it's going to be at the value of x and the value of negative 1. Now we're going to graph these in a little bit, but just understanding how to calculate that asymptote. And then right here, I'm going to go ahead and make my denominator equal to 0. So I have 3x minus 1 equals 0. going to do my inverse operations, and then divide by 3, and x is going to be 1/3. So goodness gracious, it's a fraction, but don't be afraid of the F word. It is going to be an asymptote at x is 1/3. So we're able to figure those out. And moving on here to horizontal asymptotes. Well, asymptotes, horizontal asymptotes is going to be when the denominator is going to be equal to 0. So what we do here is not when the denominator is equal to 0. We're going to work on figuring out the end behavior as x approaches. And when we work with horizontal asymptotes, what we're going to do is we're only going to be focused on the leading term of the numerator and denominator. So if I pull those out here on this example, so I've simplified, right? It's pretty simple here. And then the numerator and denominator exponents, let's focus on that. So I have negative 2x over x. And again, I just pulled the two leading terms out of the numerator and denominator. And what happens here, just think about it, x over x becomes 1. So it turns out that my horizontal asymptote is going to be y equals negative 2. Because as my function, since x over x cancels out, it's as x approaches 1,000,000, right? I would have negative 2,000,000 over positive 2,000,000 and 1. Well, that's really an insignificant value as the larger number, as my number gets larger, this 1 over here becomes very insignificant. That's why we're able to ignore it and just say, hey, it looks like my horizontal asymptote would be negative 2. Let's see here, looking at this example, I have x minus 2 over, I'm going to have to multiply that out, and that would multiply out to x squared minus 6x plus 9. And again, I am only worried about the first two terms, okay? My first terms here. So I have, if I pull that out, I have x over x squared. And if I were to simplify that, that would end up becoming, 1 over x. And as x approaches infinity and gets larger and larger and larger, actually it seems to be approaching 0, because it may seem like not very significant right now, but if x is 1, sure, we have the value of 1, but if x is 2, then it's 1/2, and then x is 3, it's 1/3, x is 4, it's 1/4, so it keeps getting smaller so it's approaching 0. So if x is 1,000,000, gosh, 1/1,000,000th is very tiny, but it's even more insignificant as we get larger than 1,000,000. So your horizontal asymptote here would be 0. Moving on here, doing the same thing here. Horizontal asymptote, well, if I look at just these first two terms, I have 2x squared over 3x. And if I were able to cancel some of these out, right, that would end up being 2x over 3. So as x approaches infinity, this number is just going to get larger and larger and larger. And it's never going to hit a point where it just can't go any larger, because there's nothing stopping it. In this case, the denominator is just 3. If I have 10 in there, or 1,000,000 or 10,000,000, it's going to keep approaching the y value, is the output's going to keep approaching infinity also. So there is no horizontal asymptote here. We have none. And then let's see here. And this horizontal asymptote was x equals 0. Not x equals y equals 0. And then this last example here, again, focusing just on my two leading terms, I'm going to have 3x squared over x squared. So x squared over x squared is going to cancel out. So it's going to end up turning into 3. So my horizontal asymptote is going to be y equals 3. And now let's see if we can possibly use the vertical and horizontal asymptotes to graph a few of these. And that way we can sort of tie it together. So, all right, we're going to go ahead and graph these. And we've already done these. And remember, my vertical asymptote, and then my horizontal asymptote. My vertical asymptote was when my denominator equals 0. So that is going to be when x plus 1 equals 0, so x equals -1. That is going to be my vertical asymptote. My horizontal asymptote was, eliminating my variables here. So I had -2x over x. Those cancel out, so my horizontal asymptote is going to be y equals -2. So when I go to graph these, let's just plug this in, right? I know that I'm going to have this point where my graph or my function will not reach when at -2. Y is -2. And I know the imaginary line here, this asymptote, is never going to get touched by my function at y equals 2. That's my horizontal asymptote. And then my vertical asymptote is y equals, x equals -1. So my vertical asymptote is going to be right there. So this is something my function's never going to touch. Now, if I just plug in some values, since I know that it will never touch, I can go ahead and say, well, heck, when f of 0 is going to be -2 times 0 over 0 plus 1, which is going to be 0. So I know that my function is going to be up in this area. And then when I pick some point over here, and we'll just say -5, okay? Because I know that that is way away from my asymptote. So f of -5 is going to be equal to -2 times -5 over -5 plus 1, which is going to give me 10 over -4, right? So that is going to be -2.5, okay? So I know that that point is going to fall in this area right here, okay? So I know that the general shape of this is going to look something like it's not perfect, right? But I know that it approaches both asymptotes and never touches. And that's all we have to do to graph that function. Okay, so that is going to be f of x equals -2x over x plus 1. I just graphed it using those asymptotes. Sort of gave me an enabled me to figure out where the function was going to be going. So as I look at this next function, remember my vertical asymptote is going to be when my denominator was equal to 0. So that was when we had x plus 1 equals to 0, x minus 1 equals to 0, which is x equals -1 or x equals 1. So graphing, I know x is 1, 2, 3, -1, -2, -3. All right, so it looks like we're going to have two asymptotes here at 1 and -1. Okay, so those are those lines that we're going to approach but never touch. And then my horizontal asymptote. My horizontal asymptote was going to be looking at my exponents, right? So I have 3x squared over x squared, and those are going to cancel out. So my horizontal asymptote should be y is equal to 3. 1, 2, 3. So we have 3 asymptotes here. We have one horizontal and 2 vertical. So what I want to do is I want to figure out some numbers between here, so I'll use 0, and then I want to figure out a value here to figure out where the graph exists. So when I plug in 0 into my function, I have f of 0 equals 3 times 0 squared over 0 squared minus 1, which is going to be 0 over negative 1. So it looks like when I graph that, or just looking at that point, 0, 0, that's going to be a value that's going to be real for this function. And then I know that I can't go this direction with my function because I'd be approaching an asymptote right there, and I never crossed that point. So I know that this function is actually going to go downward like that. It's going to do that. Now, so I should have a function that exists up here somewhere, but we'll go ahead and test some numbers anyway, just to make sure. So if I plug in, let's see here, f of, we can do negative 2. F of negative 2 is it going to be the same thing as f of 2? And I know that because right here, this is a exponent is going to be squared. So when I square it, it's going to turn positive. So I know that my negative x value would be positive. So I can just assume that those two things are going to be the same, or I can't assume it. I can go ahead and make it mathematically so. So I'm going to have 3 times 2 squared over 2 squared minus 1. So this is going to be 12 over 3 or 4, right? So at negative 2, we're going to have a 4. At positive 2, we're going to have a 4. So I know that this function exists up here. But never crosses over our horizontal asymptote. So there I was able to graph that function and showing that that's where it's at. So my asymptotes just give me a guide in which to draw my lines that I'm approaching. So there you go. Hopefully, big picture, as you can see that we have this function that approaches this horizontal line right there. Horizontal asymptote of y equals negative 2 and a vertical asymptote of x equals negative 1. Same thing down here, same asymptotes. And then, of course, this function right here. Hopefully you can see it a little bit better now that I've zoomed out. And again, not very difficult. Just throw a couple of points in there and it lets you know just the shape of the function. And I guess the next thing would be to identify some of the characteristics of this function. And hopefully you recognize these. These are the same transformations that we get with generally every function. So knowing, just like in a quadratic or an absolute value or any of those that we've dealt with, A stretches or shrinks it, and then my h value will move it left or right, and then my k value will move it up and down. So if I have a function, okay, and again, so a stretches it, so I know I have a function that's been stretched by 2. X minus h moves it left or right. So h here in this case is 1, so that means I have moved right. I have moved right plus 1. And then k moves it up or down, and here I have 4, so that means I have moved my function up 4. And so when I look at that, my asymptote, well, my horizontal asymptote is going to be 1, 2, 3, 4. It's going to be this right here, because my original asymptote when it comes to horizontal asymptote is going to be 2 over x, which is going to be 0. As x approaches infinity, the horizontal asymptote approaches 0. But we have 0 plus 4, so therefore we have been shifted up 4 units. So that's why my asymptote ended up at 4. Now, my vertical asymptote is going to be when my denominator is going to be 0. So I have x minus 1 equals 0, or x equals 1. And in that case, my horizontal asymptote is right here. And that only leaves me to plug in a few values to see where I'm at. And so if I just pick one value, and I'll just say that f of 0 is equal to 2 over 0 minus 1, plus 4, so I have negative 2 plus 4, which is negative 2. So I'm going to be at 0, I'm going to be at negative 2. So that means I should have my function is going to be right down here. Something like that, right? It's not perfect, but that's where I'm going to be. So if that's going to be where I'm at, then the other one's going to be up here, right across from where my asymptotes intersected. So that's being able to graph and just recognize what's going on in my functions. There you have it. As we talk about graphing rational functions, you need to make sure that you understand how to get the vertical asymptote. The vertical asymptote comes from your denominators where your domains don't exist, which make your functions into undefined values. And then my horizontal asymptotes is going to be the comparing my exponents and canceling them down from the first term and see where we're at, and that will give you a value that it's going to. So we want to find and graph the vertical and horizontal asymptotes. We want to evaluate the functions at values on both sides of the asymptotes to determine the behavior of that function as it approaches each of those asymptotes, and then plot and connect those points. So again, not too difficult when it comes to plotting points. Just plug some points in and graph them, and that will drive your asymptotes also.